Hello and welcome to this tutorial on automatic machine learning. What AutoML is and why is it so important? So AutoML can be used for automatizing machine learning workflows, which includes automatic training and tuning of model hyperparameters like the number of layers, number of neurons per layer, in the case of convolutional layers, for example, number of filters, the size of the filters, the type of the activation function, and so on. So for the purpose of this tutorial, we are going to implement the code, Python code, using a library called autokeras, which is built on top of the famous keras API for machine learning and convolutional neural networks. So first we're going to import from this keras library didactical dataset called Cipher10. So Cipher10 contains 60,000 32 by 32 color images, is a public available dataset. It as the name suggests, it has 10 classes with 6,000 images per class, and is divided into 50,000 images per training and 10,000 for testing. We may see here some examples. So I have defined a main function where I loaded the training and testing parts of this Cipher10 dataset, and I created a list of the class names as defined on the website, and then I have defined an output path for saving results of the AutoML. So let's see, from autokeras, import autokeras as a key. Now let's see what can we do here in the main function. Let's say, for example, that we can say we can build a so-called auto model. And let's say we make this in a function called build model. Okay, so now let's define here on top of this function build model, and try to define our neural network architecture into this function. Okay, so let's first define an input layer. So in this case, we are using the functional API of the keras library, which can be also used in autokeras. So let's say we define an input layer, and then we define let's say a CNN layer, convolutional layer. Okay, AK conv block. We just give it the input layer as a parameter. Let's say now that we want to define another CNN layer 2, for example, ak.conv block of input layer of CNN layer. Now let's assume we want to add a dense layer ak.dense block. You see how easy it is to define this architecture. CNN layer 2. Okay, so here, although we have specified a layer, this convolutional block may actually have 1, 2, or 3 convolutional blocks. So if we look inside it, let's look a bit into the actual function, into the actual class conv block from the autokeras library. We will observe that there is a method called build, and in this build, we have the number of blocks equals to 1, 2, 3, default is 2, and also the kernel size. Okay, so we have a kernel size varying 3, 5, or 7. So these are the values that this library, autokeras, is exploring. Okay, good. And let's assume that we add the dance layer 2. Dance layer. Okay, and now let's say an output layer, ak.classification head, and we need to specify here the number of classes. Number of classes in our case is 10 of dance layer 2. Now this auto model will be defined as ak.automodel.automodel, and we need to define the input layer, output of the model, and then how many trials, how many variants of the hyperparameters for the autokeras to try is defined in max trials. Max trials equals, let's say, 20, and then for the reproducibility of the results, there is a seed which takes a value, and we also want to give it a name. Let's say AutoML. Good. And this function will return this auto model. So now we have defined our function, and we can continue our main function like this. So now we can actually call for this automodel.fit. So it's similar how we do it with keras. We can also do it with autokeras. Fit train x, train y, validation split. So the parameters of the fit function that are valid for keras are also good for autokeras. Let's say 0.2 for 20% validation split. Number of epochs for each trial. Okay, so we have defined 20 trials, but now for each trial we have to specify the number of epochs, and batch size. Okay, let's make it 64, and verbose to see some progress. I'll to just observe at each epoch values of the accuracies. Now we can also evaluate automodel.evaluate this model, and then let's say that we want to save the best model, that the best variant of this architecture that has been obtained from the 20 trials, and for that we call the export model function, and let's say we want to save this in a JSON file. To JSON. Okay, and for this we need to import something here on top. So from TensorFlow.keras.models import model from JSON. Okay, TensorFlow autokeras.model.